Okay, folks, we're going to try and put everything together here and add a little bit more information to the picture that we've been talking about. We've been dealing with kind of with this part of the graphic. We've been looking at how we can take the number of particles and we can turn it into the number of moles. So we can do that by dividing the number of particles by Avogadro's number, or we can take the number of moles and multiply it by Avogadro's number and get the number of particles. And so that's one way of thinking about it, or I gave you this triangle so that you could use it to, if we were trying to find moles, we would take particles divided by Avogadro's number, just like it says here. And if we were trying to find a number of particles, we would take moles times Avogadro's number. Okay? So that gives us some relationship that really works. But we just recently introduced in the last video the idea of molar mass. And so now we can take our moles and we can turn that into a mass so that we can go to the scale in the lab and actually get a certain number of particles measured out. Or if we're given a certain mass, we can figure out how many particles are in there. So if we take the mass and divide it by the molar mass, we end up getting the moles. And we can see that here in our little triangle again. Moles is equal to mass divided by molar mass. Or if you have the number of moles and we multiply it by the molar mass, we can figure out what mass of substance we have. So again, we can see mass here. This means the mass that you might be taking in your beaker is found by taking the moles and multiplying it by the molar mass. And so I'll give another little set of formulas to help us kind of convert from moles and particles to mass. So the combination of these two triangles is going to let us do a fair bit of calculation around moles and molar mass and particles. You may want to get this graphic and put it somewhere so you have the formulas and things that you need to be able to do the next few questions. Right, so we can turn that relationship, let me go back, this relationship into another formula. We already had one formula, but this is our second. And you can say this formula is true, that moles equals mass over molar mass. Right? So we can use that triangle again, and we can generate all of the other possible formulas. So if we use the triangle, we will see that mass is equal to moles times molar mass. And if we want molar mass, we can see that you would then take mass and divide it by the number of moles. So those three formulas are going to let us calculate any one of these variables, and there's three variables in the formula. But remember, you'll always have access to these triangles or this graph of relationships. You don't need to measure or necessarily memorize, the formulas. Just get good at using them. So it gets right into a question that looks something like this. How many moles of sodium carbonate are in 25.6 grams? Well, we haven't really done one like this before, so let's set it up. We have a given mass. We have a mass of sodium carbonate. Well, that's 25.6 grams. Okay. The question is asking us to come up with moles. So we want a measurement of how many particles are in there, but we're going to measure it not in number of particles, we're going to measure it in moles, 6.02 times 10 to the 23rd particles per mole. So we'll measure it out in moles. Well, we've got mass and moles. Let's go back and look at our formula here. So we go back to these triangles, and we see this one here that has mass and moles in it, and molar mass. This one has particles, moles, and Avogadro's number. Well, we have mass and moles. So this is the triangle we're going to want to use. Let me bring it forward to our question. Paste. So there's the triangle that we're going to want to use. So if we've got mass, we want to find moles, then we need molar mass. We need to have at least two of the things in the triangle in order to solve the equation. So we'll put down molar mass equals, well, now we have to figure out the molar mass of sodium carbonate. So the first thing you need to do is get the formula for sodium carbonate, Na2CO3 is the formula for sodium carbonate. And then you'd have to go through the process of adding up each one of the atoms. So there'd be two NAs at, let me just double check, I think it's 22.99 is the mass of the NAs. Yeah, 22.99. And then I know, so let's go back, put that into our formula. So it would be 22.99 grams per mole. We've got two of those. We've got one carbon at 12.01 grams per mole. And we've got three oxygens at 16 grams per mole. And you don't need to write this out every time. Once you get good at figuring out these molar masses, you can just do it in your calculator if you wish. And then we'll calculate what that'll come out to as an answer. So the molar mass is 105.99. 105.99 grams per mole. Okay, so that's the first part of the question. We have to get that molar mass. But what we're being asked to find here is the number of moles. So now we have to bring in a formula that'll help us do that. So if we take a look here, moles is equal to mass divided by molar mass. And we know the mass that we were given is 25.6 grams. And we're going to divide that by the molar mass of 105.99 grams per mole. And again, we run that through the calculator and we get 0.24. So we got 0.24 moles of sodium carbonate. Okay. So fairly straightforward question, just a few steps. Sometimes you have to calculate this molar mass. So that was our first step, get the molar mass. And then once you have the molar mass, then you can solve the problem you were asked to solve, which is how many moles of sodium carbonate are there. Let's try another one here. This one says how many moles are in 10 grams of water. So I'm going to grab our triangle again, just so we have that to access. Copy that. Let's write down what we've got for data. So we'll get a pen here. We, again, want to know the number of moles. How many moles of water do we have? We have the mass of water that we were given in the question, which is 10 grams. And then we need the molar mass of water. So if you work that out the way we've done in the past, you end up with a molar mass of 18.02 grams per mole. Okay, I didn't just look at that, I've done that calculation before. It's going to be, of course, 2 hydrogen atoms plus 1 oxygen atom, and that comes out to be 18.02 grams per mole. Okay. Now again, we want moles, so we cite our formula, moles equals mass divided by molar mass, which equals 10 grams divided by 18.02 grams per mole. And we get a final answer in moles of 0.55. So we have just over half a mole of water, which kind of makes sense. 1 mole of water weighs 18 grams. You've got 10. So you've just got a little over half a mole of water if you go into the scale and you take 10 grams of water, you'd have just a little over half a mole of water. Okay? All right. Here's another one. Why don't you give this one a try? Maybe pause the video after you've read it and see if you can figure it out. It's a little more complex. It's going to bring together both of the triangles. So you're going to need both sets of formulas that we had before. And you're going to have to do this in 2 steps. But Let me leave it with you for a minute. So pause the video, give this one a try, and then come back and take a look at the answer. Okay, so let's give this a try now and see what we get. So we've got a mass of sucrose, which is sugar that's found in pop. So the mass of sucrose is 40 grams. So mass equals 40 grams. We want to know how many molecules. Well, we've got a mass, and in this triangle with numbers of molecules, mass is not in there. Like number of particles is what we're shooting for. So we're trying to get this number here. How do we get there? Well, we have been given mass. This is the formula for sucrose. So we could easily get the molar mass of sucrose because we have its formula right there. So that would mean that we could come up with this number. And since we have two things in that triangle, we could solve for moles. And then if we notice in the next triangle, which has the number of particles, the number of molecules, those moles reappears in there. So we could take that number, put it in here, and then we would know Avogadro's number, we would know the moles, and we could figure out the number of molecules. So a little more complex question, but just if you look at the triangles and break it down into steps, I think it's still fairly doable. So if we look at the molar mass, let's get the molar mass of sucrose. We're going to need that first because the first thing we're going to do is use mass and molar mass to get moles. So if we calculate out the molar mass, it's going to be 12 times 12.01 plus 22 times 1.01 plus 11 times 16. So the molar mass is going to be 342.34, right, grams per mole. And so that'll let us get moles. So that's our first equation we have to use, is let's get the moles figured out. So moles, again, equals mass over molar mass equals 40 grams divided by 342.34 grams per mole equals 0.12 moles. So that's how much sucrose we have. We have 0.12 moles of sucrose. Okay? So that gets it into moles, which is a way of measuring particles, but the question would actually now like to know how many molecules are in that many moles. So we have to go to the next step, and we need a new formula. So the next step would be using this triangle. We know moles, we know Avogadro's number. Now we can find the number of particles, or in this case, the number of molecules. So step 2, we go and find the number of sucrose molecules, so not moles, but molecules, and it's going to be equal to the moles times Avogadro's number. So we're going to write down moles times Avo's number. That's going to equal 0.12 moles. There's a decimal in there, sorry. And then we're going to multiply it by that big number, 6.02 times 10 to the 23rd. Okay. And let's see how many molecules we've got. We end up with 7.22 times 10 to the 22 molecules. 7.22 times 10 to the 22 molecules. Okay. So a little more complex question, but if you take your time and you map out using these two triangles what things you have, you should be able to find a pathway of getting to the amount that you want to calculate. So again, we were given mass, and we can always find molar mass. So let us put it into moles. That lets us jump to the second triangle where we have moles, and then we can divide, or sorry, not divide, we can multiply moles by Avogadro's number to get the number of particles. Okay, so that's the kind of questions we're going to be working on. Some of them will manipulate these two triangles at the same time. Some of them will just be like this one where we're just using the single triangle. But you can use the formulas by having both triangles available, map out which things you have, and then just looking for a pathway to get to the variable that you want to solve for. Okay, so I think we'll leave it there. I'll post a few more questions and answers in another video just so you can see a few more things of how these questions work. And I'll put up a worksheet that you can work through some questions and give this a try. Okay, if you run into problems or you have questions about what's going on, just send me an email or post a comment and we will deal with it as best we can. Okay, take care.